Hi, hello everyone. We are the Hive Mining Group. This is our final presentation. My name is Tate.
My name is Evan.
My name is Ben.
My name is Shrinidhi.
My name's Sarah.
I'm Sonia.
And our last group mate, Andrew, was not able to make it today. All right, so the objective of our project is to ask the question, how are changes in the world affecting biological systems? Now, to do this, we decided to use bees as a model and to look at the possible adverse effects of electromagnetic radio frequency waves on bees, and there being a possible correlation between the rising amounts of electromagnetic radio frequency waves today and the rising bee mortality rates. Now, to do this, we're going to use a machine learning program that has been trained on our videos to accurately and precisely detect any physiological response to the electromagnetic radio frequency waves that we might see, or to let us know that the effects are simply trivial.
For the actual experiment, Professor Martin was kind enough to offer his garage, which happened to have a hive in it. And how it works is that before the bees can actually go outside to pollinate and do whatever they need to do, they have a choice to make. And that choice can be depicted to the right here. They have to go through either a left or right tube, with one of those tubes having a DC or AC magnetic field around it. And then we'll also have a camera set up above that so we can actually see into it, because that section is going to be glass pipe, while everything else is PVC pipe. And what we're looking for is any sort of behavioral change that the machine learning could pick up. And well, this could be literally anything. They could do a 360 as they go through it. They could salute you. They could do whatever. We have absolutely no idea. And part of the experiment is also making sure that we have it completely controlled as we can. And part of that is going to be the light, which is why we created a box in order to block out all outside lights. We have a consistent light source, which we use a lamp for. And then to control this whole experiment, we're going to use a Raspberry Pi, which is a computer. And if you'll go to the next slide, please. So you can see in the right here, this is the completed experiment. This is the setup as of right now. It could be, room to change. But as you can see, we have a PVC pipe coming out of the hive. It's going to come around and go into the box. This box, there's no light other than the light that we put into it. And then the bees are going to go through that and go outside. And above it, we stick our computer, which is going to run everything. And then, yeah, that's the experiment.
Okay, now, so first, what we did was we built and programmed a DC current and attached it to the bee apparatus. So essentially the way we programmed it is that on the Raspberry Pi, we programmed the circuit to ensure that it has different states. So by states, we mean that the circuit will be going on for an hour and then will be like off for an hour. And we basically collected data from the Raspberry Pi and used machine learning for it. And then we wrote a second program for the AC current, which is essentially an alternating current. This is different from the DC current because an AC current starts and stops like thousands of times in a second, goes on and off like a lot, while the DC current doesn't do that. And basically for the AC current, we had to solder wires, resistors, and capacitors. And I went into Professor Martin's beehive and wrapped the coil around the glass tubes and attached it to the breadboard on top. And yeah, we collected data on the AC circuit, and the image over here, it's the oscilloscope. So basically we just tested the AC current by using the oscilloscope, which shows if current is running or not.
So using the video data that we collected in the Hive monitoring apparatus, we gave these videos to a neural network to see if the AI could accurately predict the states of the magnetic fields. So if the AI was able to correctly classify these videos, a high accuracy would be generated, which suggests that the bees are changing their behavior in response to the magnetic fields. And throughout the course of the internship, we also debugged several issues with the software, such as fixing the cropping of the videos. So in terms of results, we ran several controls. For example, we ran a control where the compass was in the video, and this generated a nearly 100% accuracy. And we ran another control where both of the glass tubes were covered, and this generated an accuracy that suggested that the neural network was guessing. Both of these were the expected results for these data sets. And when we processed other data, we generated high accuracy, and we found that there was actually a strong temporal correlation. So we believe that the AI was actually able to learn the hourly switches of the states of the magnetic fields based on the strict daily routine of the bees that corresponds to the time of day. And if you look at this graph, we ran a test where we sorted the videos into 12 different classes based on the hour of the day. And if the AI was guessing, we would expect around an 8% accuracy. And if the AI was able to accurately predict all the videos, we would expect 100% accuracy. But we were getting around an 80% accuracy, which is strong evidence that the AI actually was learning the states of the magnetic fields based on the time of day.
So regarding the camera, we started with 2 wooden frames and we wanted to lodge the camera between the two. So one was filled with cardboard, the other one was filled with glass. And we ended up putting, I don't know if you can see, the left and right pictures are both the frames that we were working with. So in the middle, we put the camera, and on the sides, there was 4 IR lights, and we connected them together to the center of the camera. And then we used power over Ethernet. The Hive is all the way to the left on the bottom picture, and that's exactly where we placed it in.
Because we placed a camera with a really wide field of view inside of the Hive, the original images that the camera took were really distorted. So as you can see over here, as you move away from the center, the image becomes really compressed. So in order to combat that, we used the OpenCV camera calibration library, which basically, in order to use it, we took a bunch of sample pictures of a 9x6 calibration chessboard. And we had to do it from various angles, and running it through our code, we were able to determine a few constants specific to our camera. And after that, we used the constants to flatten the image into a single plane. And because we want to take video inside the Hive, video is essentially just a lot of pictures, but our original undistortion code was pretty slow. So we used multi-threading to split the task of undistortion into 4 threads, which allowed us to reduce our execution time by over half. And you can see over here, this is the completed video. So our next steps are to randomize the timing of classes when collecting data in order to avoid temporal correlation, run additional experiments with different fields in different tubes, and then use the Hive video for future experiments such as counting the bees to determine colony health. And that's it.